Hey everybody, we're writing this down in our books. What we're going to look at now is transformations and how they affect the spread. So let's start with a really simple data set, something like this. I'm not even going to define what it is. I'm just going to say we've got a data set that goes 1, 2, 3. Boom, 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 boom. So 1, 2, 2 2s, and a 3. And I calculated that for this data set, which I'll call X, the standard deviation is about 0.8. Now imagine that we do a new data set down here, and this one is X plus 1. So in other words, everything is going to get 1 bigger, which means that the values are now going to be 2, 3, and 4. We'll have 1, 2, 2 3s, and a 4. And I want you to notice something. While the center moved, right? The center, which was at 2, has now moved up to 3. The spread did not change at all, or at least it doesn't appear to. So, like where your range here was 2, your range here is still 2. So, funny thing happens, even though we shifted to this data, the standard deviation is not going to change. So, first thing that you need to know today is that shifts, anything where you add or subtract, they will change the center, but not the spread. This is really easy to see right here when we look at our samples of human height data set. So get this out if you haven't already. We already did a bunch of work and we saw that when everyone grew by 10 inches, remember X was their height and then X plus 10 would be growing 10 inches. We found that that made the mean, the median, and the mode increase. Well, let's see what happens to the standard deviation. Right here, I'm going to type standard dev of, let's see, I want X, which is from here to here. So the standard deviation of the heights is a little more than 6 inches. Now, if I do the standard deviation of the shifts where we grew everyone by 10 inches, what's going to happen there? No change. Likewise, if we wanted the range, here's how you find the range, by the way. You do the max. So we would do the max from here down to here, minus the min here to here. For all I know, there's actually a range button. You can check and see if that's the case. So that's 25 in this case, and it's 25 for the other data set too. Now, that's when we took everybody and we added 10 inches to their height. What about in this case? What if we doubled everyone's height? Is that going to keep the spread the same, or is the spread going to change this time? Well, let's see. So right here, we have doubled everybody's height. So I'm going to do standard deviation of boom, 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 boom. And you can see that this 6.27 became 12.55. So when we are rescaling something, we can see that the standard deviation did change. And let me show you why. We're back on our notes, and let's suppose we take this data set right here, the original one, and we double everything. So now this is going to be 2 times X. That means that this 1 is now going to be a 2, that these 2s are now going to be 4s, and that this 3 is now going to be a 6. Well, you can see that things are more spread out now. So this is called a rescale because we are multiplying. A rescale is any time that you multiply or you divide by a number, and a rescale will change both the center and the spread.